research and teaching in the area of automation, so ranging from industrial automation over to home and building automation and also to wireless sensor networks. And our areas are like deep integration, security, safety, smart grids, smart cities, Internet of Things research, wireless sensor networks, and Web of Things, depending on the research group and the people. And also a bit standardization, so we are active in the iotsys and also have a cooperation with the KNX Association, which is a quite important home automation standard in Europe. So iotsys addresses the interoperability challenge in the Internet of Things. So in the Internet of Things, you have a lot of application scenarios, you have a lot of domains, a lot of the existing technologies, and for some use cases, you want to interconnect them. So you have a big interoperability challenge, and motivating application scenarios can be found, for example, in the domain of smart homes, if you have to connect your residential appliances with maybe some photovoltaic e-car charging station, maybe some smart meters, or within smart buildings, you have to connect a lot of different existing technologies. And also in the smart grids, there are a lot of different, like more or less important technologies. For example, as mentioned, KNX is quite important in Europe. Then you have backnet for building automation systems. You have Z-Wave, you have wireless inputs for reading out smart meters. So these are all existing technologies. Of course, it would be nice to have in future everything based on, for example, 6LoWPAN, IPv6 communication and web services, but currently there are a lot of existing technologies which have a lot of market share. So how can we interconnect all these different technologies, and how can we integrate them? There are a lot of existing approaches that allow to combine different technologies to have one common integration layer. And for example, in the area of building automation systems or home automation systems, there are a lot of existing standards that use web services for this. So web service-based communication. For example, we have DPWS, UPnP, you have iotsys Open Building Information Exchange, you have backnet WS, OPC UA. So these are all existing standardized approaches to integrate the different technologies. And recently you have also this IoT-related standardization which is ongoing. For example, this constrained RESTful environments where you try to have IP connectivity and web services on constrained devices like these ones, like development boards with microcontrollers and usually better operated, and you try to connect them to the internet. I think a lot of people here know this kind of technology. It's also the open source domotics group is doing a lot of great stuff in this area. And here you also have like existing standards developed. Some are developed by, for example, ITSI. Then you have the Open Mobile Alliance, the IP on Smart Objects Alliance, and there is also a lot of different activity ongoing. So the problem is there needs to be found a common communication stack, a standardized stack that also includes the application layer and the information models and provides interoperability among new Internet of Things devices. And in the best case, it's reusing as much as existing standards as possible. So this is a big table describing all the different options you have currently for creating a communication stack for your IoT device. So on the application layer, you have a lot of different options. You can use a lot of different technologies for encoding your messages, like XML, JSON, or EXI. Also for message exchange, you can use HTTP SOAP or constrained application protocol, or you can use some messaging-based protocol like XMPP. So there's a lot of different alternatives and heterogeneity there. So the idea behind iotsys is like instead of running a control network specific application protocol, or instead of defining a new communication protocol, we use OBIX together with a very efficient protocol binding. So this idea was already stated in 2009 by Zach Shelby. So instead of defining like a custom application layer protocol, we can reuse the existing ways of building information exchange to have one common communication stack in the Internet of Things. So So iotsys is kind of a reference implementation for that. It's like an integration middleware, but also for the communication stack and reference implementation. And it uses at the application layer and also on the information model side Oasis Open Building Information Exchange. It provides different information encodings. So if you exchange your messages, you can use different ways to encode them. And also for message exchange, you have different web service bindings. And of course, you can use IPv6 connectivity. So it's on the one side a reference implementation for constrained devices based on Contiki. So you can run it on microcontrollers equipped with wireless technology. But there is also a gateway part based on Java that allows to connect existing technologies. And currently we support BACnet, KNX, and Ocean, wireless MBUS, RFID, and also some non-building automation technologies, for example, weather data. And you can use either HTTP or the constrained application protocol, depending on your use case. And also, depending on the usage scenario, you can use different encoding. So, for example, if you want to access a device or a gateway from a browser, HTTP together with JSON would be the right option. But if you want to have communication between different devices, then the constrained application protocol together with XML or JSON or EXI would be a better fit. And it's also providing like a transparent IPv6 addressing for each device. And what is also innovative in the project is it provides a peer-to-peer interaction mechanism for IoT devices based on IPv6 and COA. So that's kind of a contribution of the project or like an innovative part. And at the gateway side, you can use a HTML5 control interface to access all the different technologies and also to create control logic to wire them together in a graphical way. I will demonstrate it afterwards with this demonstration case. So, in short, the stack looks like this. You have like a common integration on Oasis Open Building Information Exchange with some common contracts. And then you can use different bindings and encodings to interface your devices. So at the end, you have like from the application side, like one common interface based on this RESTful web services and one common representation of all your different devices and technologies. So it doesn't matter if it's like a very constrained device or a new IoT device or an existing common building automation system. It's like one common view from an application side. Yeah, so the project consists of two parts. One big part is the Java-based gateway, which runs on Java 7 and uses also OSGI at the runtime. And it provides protocol bundles for the mentioned technologies. And it also runs a web server for hosting these web service interfaces and also to provide the HTML5 user interface. And it provides also security features, and it can be deployed on any embedded PC that supports Java. So, for example, you can use the Raspberry Pi. And for the iotsys devices, we use this Contiki open source operating system, which is quite popular for these constrained devices. So, why did we choose Oasis Open Building Information Exchange for the application layer? And for example, MQTT or any other technology. OBIX was always designed around this RESTful design paradigm, meaning that you have you use URIs and web technologies to interface your devices. So it was designed with REST in mind from the very beginning. So the whole standard is kept quite slim, and it just standardized, for example, a simple object model, how to represent all your devices and appliances and building infrastructure, and also some common features like histories, time series, alarming, what you can typically find in a building automation system. And recently, the OBIX committee also added a protocol binding for the constrained application protocol and for EXI, which makes the standard fitting on constrained devices. And also some of the Internet of Things standardization activities OBX goes in this direction. So for example, the ITSI is also standardizing OBX for integrating existing home building automation systems. And there's also a kind of a big industry support already. So for example, Tritium, which is now belonging to Honeywell, is one of the main drivers behind OBX, and also IBM is using it for the Chester Bridge, and also IBM Germany is using it for the Smart TV Alliance. So it's has also some industry support. And the object model in OBX is quite simple. So everything is an object, and you can have multiple children or references to other objects, and you have either complex objects or basic data point objects, so-called value objects representing a Boolean field or numerical value from a sensor. So this is the whole OBX object model, which is kept quite simple and generic. And for representing more information, you can use or more semantics. You can use like contracts defining how to structure different devices and appliances. And besides this object model, it also adds standardized representation for data points, watches, histories, feeds, and anomalies. And as mentioned, contracts can be used to define custom types, for example, to represent certain features of KNX or other building automation technologies. And here, like a simple example, if you use OBX to represent the room thermostat, you have this OBX object with three data point children objects with three simple values, like a real for the current room temperature, a set point, and a furnace on value. And if you want to modify it, you make simple REST interaction. So you make a read on a complete object or a data point to retrieve the current value. So you can interface your sensors and devices from a simple browser. So you don't need any specific application library or platform library on your platform. You can just use your browser to interface and change the object values. And what is kind of new with iotsys is also this kind of group communication mechanism, because the problem with existing approaches for this using web service and constrained devices is that this is always client-server communication. Usually you always need a gateway or some control unit that interfaces with your devices. But with iotsys, based on this OBX abstraction, you can assign IPv6 multicast addresses on the data points. So the devices can talk directly to each other using IPv6 multicasting. So you can group different devices, and even if the gateway gets offline or if you have no internet connectivity, your control logic is still working. So that is one of the main ideas. So you can group new devices, use it as push button, and group it together with existing appliances, like from KNX. I will show you later. And for engineering this control logic, the gateway provides a user interface named Obelix, where you have a simple generic browser where you can interface all your different technologies, and you can simply wire together different objects or devices. And once you wire them together, the current value is exchanged, and since everything is based on this generic OBX object model, you can integrate different technologies easily. And for this kind of group communication is for very simple interaction, and for more complex interaction we have some kind of logic blocks that reside on the gateway side, and which can be used to create more complex logic. For example, you can have a PID controller, or you can have some logical comparison or numerical comparison. So therefore you have this kind of logic objects. And so the gateway is based on OSGI. You have bundles of different technologies, and you can run it on any Contiki compatible hardware platform. And for the gateway, any embedded PC platform can be used, but of course the Raspberry Pi is quite popular. extension shields to directly connect to different technologies. For example, here in this image you can see an extension port for the Skinix Twisted Pair, which you can simply plug in the Raspberry Pi. And for most of the existing home and building automation technologies, you can also simply buy a USB communication module. So based on this existing hardware, iotsys is like a Swiss Army knife for existing building automation systems. You simply have to plug it to your home automation system and you can directly interface it. So no installation is required. At the Automation Systems Group, we have a comprehensive test system for different building automation technologies. Like we have a simulation for HVAC control based on BACnet. We have a Kenix room model. We have also a smart meter and also this an ocean testbed. So based on this testbed, we are using iotsys to interconnect the different technologies. And for today, I just brought like a mobile demonstration use case. So it's like a home and building automation system in a box. It is based on, as you can see there, simulated HVAC model based on BACnet. So it's like a similar setup like you can see here on a real model with a real cooling and heating unit, but just like in a suitcase, but it's the same controller. And you have also a Kenix room model, for example, to adjust the set point and also to have some push buttons and a text display. And also some Notion and 6LoWPAN devices. So it's kind of all these technologies are combined with a simple demonstration use case. And it's also including a 6LoWPAN water router for connecting to this new IoT-based devices and Raspberry Pi gateway. And I think it's best if I simply demonstrate how it works. So I'm currently connected to the gateway. And so the user interface is based on this object browser. So the object browser on the left side provides you like an overview of all available devices. So it automatically discovers, for example, the available BACnet objects. So here we have, for example, for this heating unit or for this HVAC demonstration model, like the object, and you can simply drag it into the canvas area and adjust the value. So we can do the same for KNX, for example. So the user interface is quite generic, and you can display any type of appliance as long as it is conforming to OBIS. So can I just give you the demonstration? Okay. So you can, based on this basic generic OBIS object model, you have like a generic user interface for any technology. So once you have the technology integrated, you can simply interact with it. So this was for example, the KNX Lite. And I can now connect it, for example, with an Ocean-based device, like in an Ocean push button. And for that, I simply wire together the different technologies. So you use the data point of the one object and simply drag it to the other object. And once this is connected, you can now control KNX with an Ocean technology. So at runtime, this connection is set, and this this works for now every technology that is integrated. So you can also use, for example, this iotsys devices where you have the web service-based communication stack directly on the device. So, for example, within this device is also an accelerometer and a temperature sensor. And what I can do, for example, is I have this kind of 6-open accelerometer, and I use it as a freefall sensor, and I combine it with the mechanics text display that can perform an alarm signal. So simply track here this alarm message and connect it. And so once it's connected, just like freefall is detected, IQ6 multicast is sent out, data translated, and now we have this kind of interaction with existing Kinix devices. So with iotsys, you have this kind of common integration and also like a common user interface and a common way to create this control logic. And this is a very simple way for this creating this control logic, but you can also use logic blocks, as mentioned, to create a temperature controller or like empty connectivity. And the main feature is like if I connect these two IoT devices, then even if the gateway is shut down, the connectivity is still working because it's based on this peer-to-peer communication. So thank you for your attention. I think it was a lot of technical details. But if you have any questions, please.
Yes, thank you. We have 7 minutes for Q&A. So. First question.
Hi, my name is Hans Dr. I want to ask you about this OBIX. How do you see that in comparison to other initiatives to get to that universal abstraction layer? Is this already most of the work done, according to your experience? So that if everybody is using that now, then it's more or less the standard it should be used and will survive for the future, or is it somehow crappy and with a lot of
I think the point of OBIX is a quite generic abstraction. So it's very simple. So you have this kind of simple generic data points, and at the end you don't have a representation if it's like a temperature sensor or if it's a light switch actuator. It's kept quite generic, and also with this kind of standardization, I don't know which other initiatives do you mean, or which other initiatives do you use?
I'm quite sure that I do not know all of them, but I've seen that OSGI itself does do something in that area because they found that lack of definition as well, and many others, like Home Gateway Initiative and you name it, you know.
Yeah.
So
I think the problem here is a lot of also political issues, because a lot of companies don't want to use OBIX because it's from Honeywell, so like Siemens always says no, okay. And I think currently also, for example, Google and Nest are teaming up to create this kind of new standard based on 6-open that also specifies the application layer. And similar also Samsung together with other industry partners with this Open Interconnect initiative is also trying to define like this kind of IoT stack that should provide interoperability. But it's not decided yet, so it's still an open issue. I think the problem with OBIX, it's just lacking also the industry support. So 3D is using it, and also IBM and some SMEs, but it's not like that broad acceptance here in Europe.
another question is, how complicated is it if I would have a sensor or an actuator with me, and I would ask you to integrate my actuator or sensor in your demo box? So making that device, that concrete device, in that environment available.
I think that should be quite easy. You just have to create your protocol bundle, for example, based on Java. It depends on the communication technology you're using for your device.
Let's say it's a Bluetooth device.
Okay, yeah, then you just need to somehow create the Bluetooth connector for
Can we
Raspberry Pi.
define who is you in that context?
It's like an open source project, so we just
Okay, I have to be a developer. Okay.
we have currently no business model.
It's just for clarification, it's not just. Last question is, did you have seen any critical issue when you did communicate from your gateway application or service bundles within this OSGI sandbox down to the sensors or actuators or something? So, is there any
performance or
let's say full functionality, you know, because sometimes, well, some guys says that there's no guarantee that you have full access to the sensor capabilities or actuators running your service in the
possible
OSGI.
if the protocol is open and open standardized, like for example KNX, then you can access like every functionality.
Thanks.
So, next question.
Do you have any kind of service discovery, or how do you add new devices to the network?
Yeah, for example, for BACnet, we use the BACnet discovery services, so there's no configuration needed. You just plug iotsys on a Ethernet local area network where a BACnet controller runs with BACnet IP, and you automatically have all data points. For KNX, we use the ETS project file. For Notion, we have currently a manual configuration file because there are no discovery services. And for co-op-based devices, you can use multicast DNS or like this co-op resource directory standard. So these are currently different ways for the resource for service discovery. And the gateway itself runs also like a local DNS server. So we use DNSSD and multicast DNS. Thank you.
Next question.
What about this authentication organization? This OBIX supported here.
OBIX by itself doesn't standardize it, but we have like for HTTP we use SSL, and also like for HTTP we can use either username and password based authentication. I was already authenticated when I started the demo, or you can use a client certificate. So for HTTP we have already secured the connectivity, but for co-op it's still missing. It's still lagging, but there is also this kind of DTLS that can be used.
So the sensors all support this, or just some of them?
Currently for this firmware we have on these sensors we don't have any security.
Okay.
Because
So
it's
it's
like
everyone
also like a size issue of the firmware. So it's really a problem if you have this web service stack and all this stuff running on the sensor.
So if you're on the network, you can turn on that stuff.
Currently yes, which is yeah.
Next question.
In your device discovery, do you have any physical mapping?
Physical mapping information for KNX, we can use this topology information from the ETS. So for example, for KNX, we have this information how the wiring is done, like the physical topology, and also from the building model, like if it's like in which form it is. So it can be represented, but for the 6 open devices, we currently have no model for that.
Okay, I have a question. Dangerous place. So, as I know, you have towards this new device here. What is your experience with the 6-open memboard from Robotics?
Yeah, for example, in this suitcase, we have currently a Raspberry Pi inside, and a separate device is a 6-bit water router, which itself costs like 300 euros if you just have the router. And with the Merkur board, you can simply turn the Raspberry Pi also into a water router. So you have everything on one device. You have the water router for the 6-open devices, you have the Java-based gateway running on one device, and yeah, you can save a lot of costs and it works fine.
So you're talking about this here, the new extension board for the Raspberry Pi using the like that. So you have good experience.
Yeah, it was fine. And also, you can, with the new Raspberry Pi, you have like 2 more USB slots. So in theory, you can have like 6 open together with 4 more technologies. But usually, you will just like right size it for your deployment and just use the technologies.
Okay. Thank you very much.